As Lewis said, my name's Kyle. I am an engineer on the developer platform team at Stripe. And I'm going to today talk to you about how you can build your API quickly, but also build it to last. Pretty much things that we've learned over the last 4 years of building Stripe's API. How many people here are familiar with Stripe or have used it before? Fantastic, great. So for the people that haven't, Stripe is a payments API. We're looking to build the payments infrastructure for the internet, right? We want to help businesses be able to accept credit cards, charge subscriptions, pretty much take advantage of the global reach of the internet. But before we were all of those things, we pretty much had one single API, right? And that was the create charge API. It was like Stripe launched as a single endpoint. It wasn't even like REST-based. It was like JSON RPC. It had like execute charge was the name. But since then, we've grown much far beyond that API, right? We now have subscriptions. We make bank transfers. We can support marketplaces. But all APIs sort of start as one single method, right? So today we're going to sort of go through the evolution of like a single API method into a much larger application. So we're going to build an API, and build in air quotes here. We're going to talk through some sample code. It's going to be in Ruby using a framework called Sinatra. But if you guys aren't familiar with Ruby, aren't familiar with Sinatra, it's totally cool. It's like almost looks like pseudocode. And ask any questions if you're sort of confused about what you see up on screen. So the endpoint we're going to be building is like V1 of Stripe, just the charges endpoint, right? I can make it bigger if you can't see it in the back. I can sort of talk through it. I actually can't make it bigger, sorry. So the first thing you usually do in a method is just authorization, right? And so what we're going to be doing is someone's going to be passing in an API key. We're going to be getting that API key, loading up the related user from the database, and making sure that the user is valid and the key is correct, right? So that's like a very first step, just to make sure we get the user. Now the next thing is we're going to do some basic validation. So we're going to check to make sure that they've passed us a card number, right? And check that the card number is the correct length, right? Then we're going to check to make sure that they actually passed us an amount to charge on the card, and make sure that they're not like asking us to charge like 100 billion pounds or something, right? Making sure that it's like a reasonable amount. And once we and returning any errors, right? Returning any errors if the amount or the card number is invalid. And lastly, we're going to go ahead and like abstract away all of the like create charge magic that Stripe does. This is like creating database objects, going out and talking to the card network, going ahead and like talking to the actual like financial institutions, right? And then once we've done all that and it was successful, we'll go ahead and return a charge with the correct amount and the card number that you used. And actually, one of the things important here is we actually return true or false, because it's very possible that we could have gone out to the card network and they said, well, that card is actually like expired, or we can't actually use it, right? So this like pretty much is what Stripe looked like when we first launched. Now, let's like flash forward like after 4 years, right? And like what has changed now in the organization and as people are using the API, and what's changed and how has that change impacted like the development of Stripe itself? So first off is we've added like way more things, right? We're no longer one API, like one single method. So a lot of that code that you saw kind of doesn't scale anymore, right? It's very hard to sort of make, if you're getting, looking at those parameters like individually, can be kind of confusing. And as you add more features, you actually add more engineers, right? And this is actually a big problem. So the Stripe API used to be like maintained by a single engineer at Stripe. And now there's a whole team, right? Not just my team, but at least more than like 40 engineers, all working on a shared code base, right? So it can get really, really messy really quickly. And that's actually like the sad part is you have kind of regrets, right? So when you first create an API, you usually make mistakes because you really don't know too much about the space you're entering. So you make assumptions that turn out to be incorrect. And the biggest problem is that, okay, if you make these assumptions and they're wrong, how do you fix them in the future without breaking integrations that were built on you in the past? Because there's nothing worse than like breaking somebody's integration, especially for us, right? And it's the same for like DigitalOcean, right? Like we are core parts of a business. So if our integration breaks and you can't accept payments anymore, you're like losing money every minute that Stripe is broken. So it's really, really important that we don't break people's integrations. And something this is more of a actual like developer experience thing. Like, is the documentation correct for your API? I bet you everybody in here who actually like has an API is probably not. You probably forgot to change something because like you changed it in code, you didn't have time. It's like some HTML file that you just don't really understand, and you just totally forgot, right? It was like 1 a.m. when you had to push the fix. And this has happened to me. It's happened to everybody, right? But when you have incorrect documentation, it makes your product incredibly difficult to use, because there's no like, with most software, if it breaks, you can be like, oh, well, I can see the bug. Let me dive in and see what's broken. But for an API, diving in is looking at a network request that goes off. You can't actually see what's broken on the other end. So your documentation is pretty much the source code for your API, right? So the question is, how do we make this better for ourselves, right? For actually Stripe engineers, so that we can make the Stripe API better for our customers. So it's important that the design that you take and the like care that you take in designing your API also applies to yourself, and you actually think a lot about code quality and the tools you have to make your APIs. So one of the first things that I think that I really wanted you guys to take away from the talk is that the imperative style that we used in those first few slides, where the request comes in and then like inside that sort of magic box, you're like picking out parameters, that doesn't scale very well, because you're really not entirely sure what a API method is going to require. So let's like take a look at sort of a concrete example of this. So this is part of the framework that actually runs Stripe infrastructure, right? This is like a simplified version of an API resource. And what we can see here, and what's different from the first example, is that we're actually being incredibly specific about exactly what the developer is going to see when we return a object from the API. So instead of just returning some random JSON blob, we're actually saying, OK, we're going to have an ID, we're going to have an amount, a card number, and a success. We're declaring exactly what type each of those fields are. And when you do this, that means that since this is declarative, you can actually write code that actually looks at this object, right? You can actually generate documentation automatically, right? You can generate client bindings. You can do a lot of stuff that otherwise you just wouldn't even know that, oh, the charge API resource is going to have an amount. It also adds a layer of indirection, which is really important. So imagine that we had the charge database object, right? There's probably a lot of like secret sort of state that like we want to keep internal to Stripe. And adding this layer of indirection allows us to do things like down here, where the card number that we show to the user is actually a redacted number, right? Because we don't actually want to show them the real card number. So this allows us to keep the card number secret to Stripe, but still show it a redacted version of it to our developers. So that's like the actual object that you're returning in the API, right? What about the actual method that is used to create it? Now this looks a lot similar in the fact that we're declaring exactly the input that we expect, right? The old method, it could have taken anything, but now we're declaring it up front, that when you create a charge, you require 2 parameters. You require the amount, and it's an integer, and you require the card number, and it's a string. And we say, OK, this method is actually going to return a charge API resource. So now we actually know from code exactly what parameters are required and what's being returned. This is really, really helpful. Say, for example, that when I'm using this method, I accidentally mess up, right? I accidentally pass a parameter that we weren't expecting. In the old code, it would have been really, really difficult to actually go through and check every parameter and make sure that it's one that we expect. But here, we can get it for free. We can write code once that says, if the parameter isn't declared here, actually throw an error and be like, sorry, you're passing in something I don't understand. And those kind of checks make it much more likely that your API will stay robust. So I talked a little bit about making documentation easy. And so we saw how if you use a declarative style, you can actually generate automatic low-level API documentation so that your API is always up to date, no matter when and where you make your changes. But that still doesn't mean like that documentation might not be very helpful, because it's like machine generated. And like, well, you require the amount parameter, but I'm actually not entirely sure what that amount parameter is. So one thing that we've done is that we've made sure to make it really easy to document stuff right in line, right? So I've declared that I need the amount, And then I can say like, well, document the amount, and actually this is the like English string that will show up in the documentation. So as an engineer at Stripe, I actually don't even know how the documentation is generated. I know I just need to use this one little statement, and then it will automatically show up in the documentation on the website. And it's a really powerful feature that makes the Stripe product better and makes our developers' lives much better as well. Now, there's one thing I really, really want to talk about, which is even more important than documentation, and that's backwards incompatible changes. So as you develop an API over the years, you end up shipping a lot of changes, right? You want to make, your assumptions were wrong, and you want to make a change. But there are people that have their payments infrastructure built on that code path, right? And so you want to be able to say, like, OK, we're going to upgrade, and we're going to add a different version. But we're going to make sure that the version you're on stays the same. And this can all be very, very complicated. And so you actually want to hide it as much as you possibly can. So let's give an example on how that works. So instead of, like, if you ask most people in here about what Stripe version they're using, they probably actually don't know, because we hide it as much as possible. So when you sign up and you make your first API request, we pin you to the most recent version automatically. You have no idea. And what that means is that every other time you make an API request, you are always hitting the exact same version of Stripe. And you get that absolutely for free. It's the default way that the API works. Now, if you say you're like, OK, well, it's been a couple years now. I'm ready to upgrade to a different version. We have documentation that allows you to change that easily. But say you don't, like you just don't care. Like I'm making charges. It works fine. That's going to continue work for years. And we're promised to never, ever break that, right? This is a tweet from somebody. So our API versions are very long-lived, but we ship new API versions at least once a month, right? And that kind of velocity allows you to like actually make your product better without being worried about breaking other people's integrations. So let's imagine that example that we've talked about, like just accepting a charge. Let's imagine that we actually wanted to make a breaking change. And that's kind of a silly change. We're going to say that, well, charges, you used to be able to pick an amount, but now we're just going to make every charge 5 pounds. That's going to be by default. Everything's for 5 pounds. So how would you actually go about doing that, right? So you're saying like, OK, well, this is going to be version 2, right? Version 1 was the beginning one. So I guess we like check that version 1, like if it's version 1 and they pass in an amount, sorry, if it's not version 1 and they pass in an amount, we're going to throw an error and be like, sorry, you can't actually specify amount anymore. It's just 5 pounds. And then on the response side of things, when we're actually returning that response, we're going to just delete the amount because it's always going to be 5 pounds. Now you can imagine that this code can get messy really, really quickly. Because if you have maybe 2 versions, it's OK. But if you have over 70, it's going to be just a huge mess of if statements. And that's why we use something internally called gates. You guys might have heard of something called feature flags. So this pretty much allows us to enable individual features on a per request basis. So what does that actually look like? So we have a YAML file. And let's imagine, so we define this new version, right? 2015 0407. All of our version numbers are dates, like pretty much when they were released. And we're going to specify that a new feature or new gate is in this version, right? And this is the fixed amount gate. And that says, OK, all charges now, they're for a fixed amount, and you can't change that, right? So let's take a look at what the code looks like now that we have this concept of like a specific feature gate. So if we take a look, now we said, OK, before we were checking what version they were on, right? And it's not entirely clear what that version was. But now if you read the code, it's actually a lot clearer, right, to a human. It's like, oh, if they have the fixed amount, and if they're like gated into the fixed amount feature, and they pass in the amount, well, that's going to be an error because they can't do that anymore, right? And it's the same way, like, oh, if they're gated into fixed amount, we don't want to show them the amount anymore. And it becomes much easier to reason about code that has these conditionals all throughout the code base. So how does that actually work in practice, right? And so what that means is that if you have all of these like checks and if statements, your code can get really, really, really complicated because the entire code base is trying to figure out exactly what version you're on. So we do something where when the request comes into Stripe, right, so the first thing we do is we check what version you're requesting, and we massage it to make it look like the most recent version, right? So say, for example, we renamed a parameter. Well, in the request compatibility layer, we'll actually take that parameter with the old name, move it to the new name, so that the code inside, like the API logic and like the actual code here, doesn't have to know about the old name. So the only old name knowledge is up here in the beginning. And then at the end, when you're finished, in like the response compatibility layer, then that's where we say, take the new name that you don't know about and rewrite it to the old name. This pretty much makes that these two layers are can be very complicated, but all that complexity is pretty much relegated just to those two layers. And the developers who are in here, they don't have to worry about it at all, which is really, really, really powerful. So how does this work? But one thing when we went back and looked at, this code, I still have to automatically, I have to write this gating check code, and you could imagine that that could be something that I could mess up, right? So how can we make it even easier for developers at Stripe to make backwards compatible changes? So remember that charge API resource that we saw? Well, instead of, we can just add an optional field here that says okay, if this person is gated into, say, this is another for future feature possibly, right? Say I wanted to allow people to specify a charity when they're making a charge, and a portion of that charge goes to charity. We could say all right, that parameter is optional, but only if you are gated into the allow donations gate. And that allow donations gate is tagged to a recent version of the API. And so that means that the whole compatibility layer, you just get that for free as a developer. So all you need to know is that you just need to include that gate. This is pretty much the same also for this is for a field on a response, and this is for the charity field on an actual request. So you might be wondering, how does this work in the real world, right? So these are some kind of toy examples, but this is very realistic in what we actually use at Stripe. So for us, it's worked really well. So we have about 173 endpoints on our API with 76 different API versions and 6 API clients. So you can sort of do the math in your head for the combinatorial explosion that happens there. And this has done a pretty good job of managing that complexity internally. So when you're designing your API, really think about it and design it for yourself, right? Declare your schema up front so it's very explicit about exactly what parameters you expect and what parameters you're going to be returning. Generate your docs automatically so other people don't have to write them themselves. And last, commit yourself to not breaking older versions of your API, because it's going to make developers absolutely love the product that you've built. We're still figuring also a lot of this stuff out as we go, and I'm assuming that over the next 4 years we'll also learn a lot more. That's all I have. I will be here after all the talks if anybody wants to talk about more APIs. Thanks, guys.